AI increase skills. Introduction, History and Future of Artificial Intelligence in Our Everyday Lives. The world has switched into sixth gear and is speeding along at a dizzying pace carried by the power of technology. We are currently witnessing a significant dialogue about the importance and impact of artificial intelligence on the development of the economy, science, society, and each of us. These discussions are often filled with emotion. The vision of robots taking over the world is mixed with the paradisiacal perspective of serving AI for the glory of humanity. Malchevsky, 2019. Artificial intelligence, once the realm of science fiction and philosophical debate, has steadily woven itself into the fabric of our everyday lives, transforming how we work, communicate, learn, and even think. To understand how we arrived at this point and where we might be headed, we must trace AI's fascinating journey from theoretical beginnings to its current real-world presence and glimpse into its transformative potential for the future. The story begins in the 1940s and 1950s, when pioneers like Alan Turing began asking profound questions about the nature of thought and whether machines could replicate it. The invention of the digital computer opened the door to new possibilities, and by 1956, the term artificial intelligence was officially born at the Dartmouth Conference. This marked the dawn of a new scientific pursuit, brimming with optimism and the hope of creating machines that could match human intellect. However, the path forward was not straightforward. In the decades that followed, AI encountered significant hurdles. The initial enthusiasm gave way to disappointment as the technology failed to live up to its early promises. These setbacks triggered two major AI winters in the 1970s and 1980s, during which funding dried up and public interest waned. But even in those quiet periods, researchers continued their work, laying the foundation for the breakthroughs to come. By the 1990s and early 2000s, AI began making tangible contributions. Expert systems found their way into specialized fields like medicine and finance, offering decision support where rules and logic could be clearly defined. On the consumer side, search engines, spam filters, and early voice recognition software started creeping into daily use, often unnoticed but increasingly essential. The 2010s marked a dramatic shift. With the explosion of data, more powerful computers, and advances in neural networks, AI finally began to fulfill its long-held promise. Machine learning, particularly deep learning, fueled a new era of smart systems. Suddenly, AI was everywhere. In our smartphones, guiding our Netflix recommendations, powering Siri and Alexa, enabling Google Maps to predict traffic, and helping cameras recognize faces. What had once seemed futuristic was now mundane, embedded in the rhythm of modern life. As we look to the future, AI's role is set to deepen and expand in ways that are both exhilarating and complex. Healthcare stands to be revolutionized by intelligent systems capable of diagnosing disease, personalizing treatments, and managing patient care. In education, AI tutors could adjust their approach based on each student's learning style and pace, making education more accessible and tailored than ever before. Retail experiences are becoming hyper-personalized, with AI suggesting products, automating service, and even anticipating needs before they're expressed. Our environments are evolving as well. Homes are getting smarter, with AI managing energy consumption, home security, and even groceries. Cities, too, are becoming more intelligent, leveraging AI to streamline traffic, reduce waste, and enhance public safety. These changes are reshaping how we live and interact with the spaces around us. But perhaps the most profound shift lies in how we work. AI is no longer just a tool. It's a collaborator. It's helping writers draft stories, designers create visuals, and developers write code. It supports decisions in fields as varied as law, journalism, and finance, enabling professionals to work smarter and faster. Meanwhile, autonomous systems, like self-driving cars and delivery drones, are steadily moving from test zones to mainstream use, promising to redefine transportation and logistics. However, with this power comes responsibility. The rise of AI presents ethical and social challenges that cannot be ignored. Issues like algorithmic bias, surveillance, data privacy, and job displacement loom large. Society must grapple with how to ensure AI systems are fair, transparent, and used for good. Governance, education, and thoughtful regulation will be critical in navigating this new landscape. In sum, AI has journeyed from speculative theory to everyday necessity. Its presence is now so commonplace that many of us use AI daily without even realizing it. As it continues to evolve, it promises to shape a future that is more connected, efficient, and personalized, but also one that demands careful thought, responsible stewardship, and a commitment to shared human values. But what is exactly artificial intelligence? Artificial intelligence, AI, is defined in the Cambridge English Dictionary as a specific computer system or machine that has certain characteristics of the human brain, such as the ability to interpret and create language in a way that appears human, recognize or create images, solve problems, and learn from data provided to it. Artificial intelligence equips technical systems with the ability to perceive the environment, process sensory information, and make goal-oriented decisions. This process is based on receiving data, raw or processed, analyzing it, and generating appropriate responses. AI systems demonstrate the ability to learn autonomously by analyzing the consequences of their actions and adapting to changing conditions. We can divide artificial intelligence into narrow, weak artificial intelligence, and general, AGI, or strong artificial intelligence. These terms were introduced by University of California, Berkeley, Professor John R. Searle. Weak artificial intelligence is designed to do a job better and faster than humans. Its role is to assist the natural cognitive abilities of humans. These are, for example, digital assistants, voice assistants, or smart homes. Strong artificial intelligence is intended to be systems that operate with comprehensive knowledge and cognitive abilities that allow them to think independently and perform various tasks that are usually only attributed to humans. In 2017, an AGI survey was conducted that ranked 45 known active research and development projects that overtly or indirectly explore AGI. These singled out the three largest: DeepMind, the Human Brain Project, and OpenAI. It is also worth mentioning John Searle's use of the term strong artificial intelligence in 1980 as part of his Chinese room argument. The Chinese room argument holds that a computer executing a program cannot have a mind, understanding, or consciousness, regardless of how intelligently or human-like the program may make the computer behave. He wanted to distinguish between two different hypotheses about artificial intelligence. The first was called the strong AI hypothesis and assumed that an artificial intelligence system could think and have a mind. The second is the weak AI hypothesis, which is that an artificial intelligence system can only act like it thinks and has a mind. Searle argues that without understanding or intentionality, we cannot describe what the machine is doing as thinking. And since it does not think, it does not have a mind in the normal sense of the word. Therefore, he concludes that the strong AI hypothesis is false. A computer running a program that simulates a mind would not have a mind in the same sense that human beings have a mind. The first Internet Network Advanced Research Project Agency was established as early as 1969. Over time, media development evolved. In 1972, computerized mail was created. A year later, the first international network connection between America and the United Kingdom was established. Then, at the turn of the 20th and 21st century, we experienced Web 2.0, based on social media characterized by multidirectional communication, openness of expression, and the use of collective knowledge, intelligence, and experience. This was followed by the semanticization of the web referred to as Web 3.0. We are currently in the early stages of Web 4.0, which is linked to artificial intelligence. The history of artificial intelligence can be traced back as far as 1950 and is linked to an article entitled Calculating Machines versus Intelligence, written by the British mathematician and computer science pioneer Alan Turing. He conducted a study based on a mimicry game. It consisted of having to guess the gender of the person in the next room with the possibility of asking questions in written form to avoid voice prompting. The aim of the study was to prove that if the human players did not guess that they were dealing with a machine, there would be no logical basis for denying the computer the ability to think. Currently, this test can be linked to the CAPT-CHA test. Other tests that confirm AGI at the human level are, for example, Wozniak's coffee test, Gortzel's robot college student test, Nielsen employment test. In 2017, researchers Feng Liu, Yipeng Shi, and Ying conducted IQ tests on publicly available artificial intelligence systems, such as Google AI and Apple's Siri. The highest score achieved by artificial intelligence was 47, which is roughly equivalent to that of a 6-year-old child. Similar tests were conducted in 2014, and the score achieved 3 years earlier was 27, which may indicate the development of artificial intelligence over the years. Marvin Minsky is considered the pioneer of artificial intelligence. In 1951, he and Dean Edmonds built SNARC, Stochastic Neural Analog Reinforcement Computer. This computer was built with tubes, valves, wires, small motors, and modeling gears connecting different neurons. The machine played the role of a rat looking for a way out of a maze to reach food. The system allowed all the movements of the rat in the maze to be tracked. A design error meant that more than one rat could be introduced there, with the result that the rats began to interact with each other. The numerous attempts they made allowed them to start thinking on a logical basis, and this helped to reinforce the right choices. The rats more advanced in their learning were followed by other rats. The effects of their actions were recorded in the system thanks to 3,000 vacuum tubes. In those days, there were no transistors or microchips yet. It is known that artificial intelligence encounters problems. These are related to general computer vision, natural language understanding, and dealing with unexpected circumstances when solving real-world problems. It is assumed that human computing is required to solve them. There are also skeptics among researchers about achieving strong AI in the future. Hubert Dreyfus and Roger Penrose. Nevertheless, it is being used in many fields: medicine, commerce, scientific discovery, education, toys, etc. 1. Interacting with AI every day. Artificial intelligence has gone from being an emerging technology to becoming an integral part of our daily lives. Without even realizing it, we interact with AI systems on multiple occasions throughout the day. From unlocking our phone with facial recognition to receiving personalized recommendations on streaming platforms, AI is behind many modern conveniences that we have come to consider normal. This subtle yet profound integration has transformed not only how we use technology, but also how we communicate, learn, and work. Advances in machine learning, natural language processing, and cloud computing have enabled devices and applications to become smarter and more responsive than ever before. This section will explore the various ways AI manifests itself in our everyday activities and how it is redefining our interaction with the digital world. Artificial intelligence has become deeply embedded in our daily interactions, often in ways we overlook. Advances in technologies such as natural language processing, NLP, machine learning, and neural networks have enabled devices and applications to become smarter and more responsive. Voice assistants and smart devices. Assistants such as Siri, Alexa, and Google Assistant use AI to understand and respond to voice commands, enabling tasks such as sending messages, playing music, or controlling smart home devices. These assistants have evolved to offer more natural and contextual interactions. Word processors and assisted editing. Tools such as Grammarly and Microsoft Editor employ AI algorithms to analyze and improve writing in real time, suggesting grammatical corrections, style improvements, and tone adaptations based on context. Text-to-speech and speech-to-text conversion. Applications such as Google Translate and Otter.ai allow you to convert written text to speech and vice versa with high accuracy, facilitating communication and accessibility in multiple languages and environments. Current trends show an increasing reliance on AI to improve efficiency and personalization in our daily tasks. The ability of systems to learn from our preferences and behaviors is leading to more adaptive and personalized user experiences. 1.1. Chatbots. Chatbots based on artificial intelligence, automated rules, natural language processing, NLP, and machine learning, ML, process data to provide answers to a variety of user questions. The history of chatbots dates back to the 1960s, when MIT professor Joseph Weizenbaum created ELIZA, one of the first programs of its kind capable of simple conversations in English, relying on a limited set of rules to process input and generate responses. Despite its simplicity, ELIZA was a breakthrough, showing that machines could simulate human communication. Today, chatbots can be divided into two main types: task-based, declarative, and conversational, predictive. Task-based chatbots focus on performing specific functions, such as answering queries about opening hours or simple transactions. They use rules, NLP, and, to a small extent, ML, to create automated responses that keep the conversation going. With structured interactions, they work well as interactive sets of frequently asked questions and answers. They are particularly useful in customer service and basic services, and are the most common type of chatbot due to their simplicity. More advanced conversational chatbots, often referred to as virtual assistants, are interactive, personalized, and able to understand context. They use advanced NLU natural language understanding, NLP, and ML techniques, allowing them to learn from user interactions, apply predictive intelligence, and analyze data. These bots can adapt their responses based on the user's profile and previous behavior, as well as anticipate user needs and initiate conversations. Examples of such chatbots include Apple's Siri and Amazon's Alexa. Thanks to their versatility and natural language processing capabilities, chatbots are used in a wide range of industries, from simple information to complex customer service and business process automation. Their growing popularity is due to their ability to enable fast and efficient interaction between companies and customers, which is particularly important in the digital age.